So in this section, we're going to cover what are called higher order derivatives. Higher order derivatives. And all that means is we are going to continue to differentiate beyond just one time. So for instance, if I tell you that I've got a function of 4x to the third minus 6x squared plus 7x minus 9, okay? So far we know that we can take a derivative. So my first derivative will be 12x squared minus 12x plus 7. Well, now I can keep going, okay? So my second derivative, so notice there's two little tick marks now. So there's one little tick mark for a first derivative, two little tick marks for a second derivative. So now I got a 24x minus 12. And now I can do a third derivative. Oops, sorry, that says 4. All right, so 1, 2, 3. Okay. So I can do a third derivative so that I've got 3 tick marks, and that's a 24. And now when we hit the fourth derivative, we change it up just a little bit. Okay, so the fourth derivative, I get tired of using tick marks, so I'm just going to put a 4. So that gives me 0. Now, what does that mean? Because you're like, okay, that says y to the fourth. Just remember, in context, you will have been differentiating. So you're not going to all of a sudden say, oh, I've got a first derivative, second derivative, third derivative, and now I'm going to raise it all to the fourth power. No, that's not what you're doing. You're following this pattern. So the notation looks the same as raising it to the fourth power, but by context, you'll know that you're taking a fourth derivative. Okay. So that being said, and if you were to go on into Cal 2 and Cal 3, you would be doing higher order derivatives quite regularly. But all we're doing in this section is just practicing differentiation with higher order derivatives. So let's go ahead and practice. So if I have f of x and it equals a negative 0.6 x squared plus a 0.2x 0.7, and I want to find not only the first derivative, but I want to find the second derivative. Okay, so my first derivative is going to be a negative 1.2 x to the first plus 0.2. And then my second derivative will be a negative 1.2. Okay, so one of the fun things that you could note based on my example and based on what we're practicing is if you have a function, if you've got a polynomial, okay, if you have a polynomial function, the number of derivatives that you can take is one more than your power. So this is a 4x to the third. That means I'm capable of taking 4 derivatives because it'll zero out at that point. This was an x squared. So I can take 3 derivatives. I'm sorry, good Lord. Yes, I can take 3 derivatives because that is one more than my power. So if I were to take a third derivative, it would be 0. Okay, so that only works, that's a little shortcut, and that only works for polynomial functions. Okay, so because if it's not a polynomial function, it can go on forever. All right, so let's try it again. We have y equals 2x to the third minus 7x squared plus 9. Okay, so my instructions are I want a first derivative and I want a second derivative. So again, you know that based on these little tick marks. So if there were no instructions to read, you would know what I'm asking you to do. Okay, so this becomes 6x squared minus 14x. That's your first derivative. Your second derivative is 12x minus 14. Okay, so it's pretty straightforward. It can get a little bit exciting if we're not dealing with polynomials. So we'll have a couple of examples of those. So let's do this one. I've got g of t equals, and I have a t squared times 4t plus 1 to the fourth. Okay, and I want to take two derivatives. So we want to look at the first derivative, and I'm not going to write the second one because I already know this is messier. Okay, so it's not going to be as clean as the last couple examples. So I know that I've got this chunk times this chunk. So that tells me I'm going to have to use product rule. The derivative of the inside on this one is not 1. So in the process of doing product rule, I'm going to have to do some chain rule. Okay, so product rule says first. So I have a t squared times the derivative of the second. So drop your exponent out front times what's inside. Don't change it. Drop your exponent by 1. And now times the derivative of the inside. So let me restate that because I kind of stumbled. First times the derivative of the second. So I drop my exponent out front times what's sitting there. Don't change it. Drop your exponent by 1 times the derivative of the inside. So first times the derivative of the second plus the second, which gives me 4t plus 1 to the fourth, times the derivative of the first. So that gives me a 2t. Now, at this point in the past, we would have stopped. But this is one of those situations where it's actually going to benefit us to clean it up a little bit, because I got to do all this again. Okay, so when I look to clean this up, I see a 4 times a 4 times a t squared, which is going to give me 16 t squared times, and then I have 4t plus 1 to the third, plus, then this one's already cleaned up. So 2t times 4t plus 1 to the fourth. So now, that's just your cleaned up first derivative. I have to differentiate again. Okay, so what does that mean? That means I got product rule with some chain rule on the inside. I got product rule with some chain rule on the inside. So I'm going to learn my lesson, and I'm going to start writing way over here. Okay, so my second derivative is going to be, so let's color code some of this stuff. I've got this times this. Okay, so I'm going to do product rule here. So I have the first, which is 16t squared, times the derivative of the second. So I'm going to drop my 3 out front, times what's sitting there, and drop my exponent by 1. So first times the derivative of the second plus the second. So that's just 4t plus 1 to the third, times the derivative of the first, which is 32t. Okay, so it's kind of messy, and I'm going to tell you right now, I'm going to run out of room here. So I'm going to drop it to the second line. So first times derivative of the second plus the second times the derivative of the first. And remember, I can flip-flop the order that I multiply in. And I just want to be clearer with how I write, more clear with how I write. So I'm going to write that up front. All right, so for the second portion, I got a plus, okay? And now I've got first, where'd my purple pen go? And I've got second. Okay, so I'm just going to start writing it underneath over here. So I have the first, which is 2t, times the derivative of the second. So drop your 4 out front, times what's sitting there. Drop your exponent by 1, times the derivative of the inside. So first times derivative of the second, plus the second, which is 4t plus 1 to the fourth, times the derivative of the first, which is 2. Now, technically, you're done. Okay, but you have to enter this into the software, so it might be worth it to clean it up just a little bit. Okay, so looking here, I've actually got a 48t squared. Okay, so I'm going to write this in black. My second derivative is, you can type all that crap in there if you want to. All right, so I got a 48t squared times 4t plus 1 squared. Okay, I have, now this is the fun part. Look, I have this many 32t of these, And then I've got 16 times 2 is another 32t of these. So I end up with 64t of the 4t plus 1 to the thirds. Okay, so there was 32t here. And then there was 4, 4, and 2 gives you 6t, or 32, sorry, t of these here. So I just combine like terms. And then plus 2 times 4t plus 1 to the fourth. So you don't have to get here. But for instance, if I asked you to take a third derivative, boy, howdy, you'd want to go here, because this is a whole lot cleaner to mess with, to differentiate, than this would be. Okay, so that's just an example of when it can get a little bit scary. So let's do it again. So I have q of t equals 8t squared minus 8 squared times 7t squared. Okay, and I want to take a first derivative, and I want to take a second derivative. So my first derivative, my bigger picture, is I have product rule, okay, because I got a big chunk times a big chunk. But within that, I'm going to have to do some chain rule, okay? So product rule says I have the first times the derivative of the second, you can't see, okay, plus the second times the derivative of the first. So I'm going to drop my exponent out front, times what's sitting there, drop my exponent by 1, and then times the derivative of the inside gives me a 16t. So again, I'm going to clean this thing up because it's awfully nasty right now. And I've got to take a second derivative. So when I clean this up, what do I get? I get q prime of t, or the first derivative of q of t, this is just going to be 14t times 8t squared minus 8 squared. This is going to become 16 times 2 is 32, and 32 times 7 is theoretically 221. However, we are always going to check our work. 32 times 7 is 224. See, that's why you check your work. 32 times 7 is 224. And I've got t squared, and t gives me t to the third. And then I've got an 8t squared minus 8. Okay, so that is my cleaned up first derivative. So I'm going to dive in and do a second derivative. So my second derivative will be, on this one, I'm going to have to do product rule with a little bit of chain rule, okay? So I have first times the derivative of the second, which is 2, 8t squared minus 8 to the first, times the derivative of the inside, which is 16t. So first times derivative of the second plus the second, so plus 8t squared minus 8 squared times the derivative of the first is 14. Okay, so I've differentiated this first chunk. Now I got to do it again. So I have first and I have second. Now, if you noticed, you could distribute this and just go a term at a time. Okay, because this doesn't have a power on it other than 1. So you could distribute this and then just differentiate each term. Well, I've already set it up this way, so I'm going to keep going. All right, so I have the first, which is 224 t to the third times the derivative of the second, which is simply 16t, okay, plus the second, which is 8t squared minus 8 times the derivative of the first. And so I get 672, okay, because drop your 3 out front. So 672 t to the second. All right, so first times derivative of the second plus the second, which is right here, times the derivative of the first, and I forgot to change my pen color. That's supposed to be red. Okay, so that is okay if you want to do that. This is raised to a first power. This is raised to a first power, so if you wanted to, you could slap those together. Otherwise, you're done, okay? So let's try another couple. Actually, let's pause that one and we'll pick back up.